Okay, let's get started. So good morning, good afternoon, everybody, and thank you very much indeed for joining us. Welcome to our sustainability webinar series in 2022. And today it's all around digitalization and sustainability. My name is David Cook. I'm the Associate Director Digital at the UK's national standards body, BSI. And I and my team are responsible for standards and best practice development and implementation within the digital sector, both nationally and internationally. So just a little bit of housekeeping before we start. So delegates, yourselves will remain on mute during the webinar. We will be showing slides from our presenters, but we will stay off video until the Q&A session at the end, where we'll pop our videos on and you'll be able to see us. Hopefully that will then mean we won't get any bandwidth issues. The sessions will be recorded for those who can't attend this morning, but if you can attend, obviously you can follow up and review the sessions themselves. These sessions are meant to be interactive, so we will encourage, or I would encourage delegates to ask us many questions as they possibly can throughout the webinar, using the Q&A function on the right-hand side of your screen. Please don't use the chat function. That's there for us to talk to you and you to talk to us and to solve any challenges. So please use the Q&A function and feed your questions in as we go along, or any comments would be appreciated, and we will try to handle as many of the questions we possibly can at the end of the session. So we will be allocating time for Q&A, and hopefully then we can walk through some of your questions and get our expert panelists to answer as many as we can. If there are any handouts, they'll again be in the right-hand side of the screen, so you'll be able to pick those up, or they'll be online later on for you to download from the website. So this morning's webinar is about digitalization and sustainability. We're going to examine embracing technologies, digital solutions. We'll touch a little bit on standardization, as well as looking at what might be a well-planned and executed sustainability strategy to deliver the best results using digital technologies. So I'd like to welcome our expert panelist speakers. I'll let them introduce themselves, but we have a fantastic set of experts here this morning. So we have Dr. Maria Nelson, Head of Innovation and Sustainability at the Aerospace Technology Institute. And we have David Pugh, who is Head of Sustainability at the Digital Catapult. They will do a much better job of introducing themselves. So I, without any further ado, will hand over to Maria and give her control, and she will take us through the next 20-25 minutes or so. Maria, over to you.
Thank you. Thanks very much, David. Good morning, good afternoon. Really pleased to be here. Yeah, I'm Head of Sustainability and Innovation at the Aerospace Institute, Aerospace Technology Institute, which I actually joined fairly recently with a background. And so funnily enough, David, my next presenter, used to be my colleague up until very recently. So I have a background in innovation and in digital, working with emerging businesses and supporting them in growing their products, their services, their businesses, and working with adopters, so with industry adopters on different types of advanced digital technologies. And I took my passion for innovation and for sustainability to really look at the aerospace sector. And you know, one of the leading sectors in the UK, and the UK aerospace sector in turn is one of the leading aerospace sectors in the world. It's also a significant contributor to climate change, so not as much actually as road transport, for example, maybe surprisingly, but about 3.5% of global warming is down down to aerospace. And so I wanted to take my passion for innovation and for sustainability and really kind of look at the heart of an industry that requires rapid transformation and rapid change in order to get it to where we want to be in terms of net zero by 2050. So that's what I'm doing now at the ATI, the Aerospace Technology Institute, supporting small new entrants to the sector as well as existing companies in innovating, in using digital technologies, but also generally innovating the technologies that may be non-digital that they're using, and ideally collaborating across new entrants and incumbents in the sector. So I'll start with my presentation today to give you a sector-specific view. This is going to be more from a kind of user perspective. So what can digitalization mean for aerospace? How can we think about sustainability in aerospace? And yeah, just a little bit of background about the ATI as well, if you don't know us. And then I think from David, you'll hear a bit more about the strategies of generally across industries. How can we think about digitalization? What do you need to think about if you want to start digitalizing and embedding those new capabilities in your business? So I think these two presentations will hopefully add up nicely, and then I look forward to your questions, as I'm sure David will. Right, it's really odd, by the way, not to see anyone and not to see myself and be basically in a room speaking to myself, but that's fine. I can imagine you all there, and I'm looking forward to your questions. So sustainability and digitalization, as I said, an aerospace perspective. First, let me tell you a little bit about the ATI. If you're not from aerospace, you might not be aware of who we are. So we are a not-for-profit, part government, part industry-funded body that promotes transformative technology for air transport. So where I'm talking about aerospace, I mean planes, building aircrafts, mainly planes, but also drones and others. And where I'm talking about aviation, it's the use of those. So those two are closely linked. We focus on aerospace primarily, but also look at aviation, so the use of aircraft. So we promote transformative technologies and also define the national technology strategy for the UK aerospace sector by way of developing research and technology, so R&T, research and technology portfolio, and funding research and development. So we work with industry, we understand their technology roadmaps, again, digital and non-digital, and we look at where we can support those and accelerate those through R&D funding from government. We also develop thought leadership, so we look at where industry needs to be going, and that's squarely focused on sustainability in the last couple of years. And in fact, we just launched a new strategy that I'll talk a little bit about in a moment. We drive innovation and support innovators, which is a lot of my job. And then we connect the ecosystems. This is about emerging markets and emerging collaborations across suppliers, supply chain lower down, supply chain higher up, regulators, funders, investors, and so on. And so it's about connecting that market and making sure that this ecosystem comes together. And overall, we'll invest more than 1 billion over the next 3 years in advanced technology to enable net zero flight. So our scope, as I mentioned, really centers around aircraft, so the aircraft technologies, but also that of course needs fuels and energy. So we're looking at the kind of interplay between fuels, especially new fuels, so sustainable aviation fuels and alternative energy sources and fuels, which will be electrification and fuel cells, but importantly also hydrogen and liquid hydrogen. And I'll talk about this a little bit more in a minute. Then airports and airspace in terms of airspace operation and generally operation and regulation of the sector. So we focus more on the middle and less on the outside, but of course the outside rings are enablers. And so those are also areas where we're advising and developing thought leadership and connecting the ecosystem. So in terms of our new strategy, Destination Zero, we've basically looked at 3 key roadmaps that need to be in place in order to keep the sector, the leading sector that it is, both in the UK and globally, so economically leading and sustainable. And the 3 roadmaps that we've developed for this is a zero carbon aircraft technologies roadmap. So that means, well, what it says on the tin, zero carbon, which is effectively electric, hydrogen, and liquid hydrogen. So electric is a little bit closer to what's possible already, especially on the smaller aircraft and drones and such. But hydrogen operated and liquid hydrogen operated aircraft is really a radical innovation in the sector that has, for good reason, over, well, more than a century now, been very incremental in developments for safety reasons, of course. So it's a leading high technology sector by all means, but it's not necessarily the most experimental for good reason. And so such a fundamental radical change, the need for innovation is really well, an interesting and challenging development in the sector. And so that's one area where digital technologies, where they can enable these new products, new designs, new manufacturing, new products to come to market faster, can really be a game changer. Then we're looking at ultra efficient aircraft. So that is about both conventional aircraft, so kerosene burning aircraft as we know it today, but also about future aircraft, all kinds of technologies that will make these types of aircraft more efficient, which means they will be burning less fuel, whichever fuel that is. And so that will cause both less emissions, tailpipe, so in the air when you're burning the fuel, but also means that you need to generate less fuel, and that is again more energy efficient. So it's about looking at things like ultra high bypass ratio engines, so different propulsion, more efficient propulsion systems, folding wing tips, and so largely incremental, but to an extent also really more radical innovation, which will be an enabler both for improving the efficiency of existing conventional aircraft and new aircraft, hydrogen and electric as well. And then we've got cross-cutting technologies and infrastructure that are really important for both, and that's a lot where some of the digital technologies that we think can be key enablers for the sector will sit. So I'll look in a little bit more detail at those. I think I've largely really summarized it already, but this is what these roadmaps look like. So it's kind of left to right, a time axis, and then you can look at what goes into one of these roadmaps. So aerostructures, advanced systems, propulsion and power, and then the aircraft concepts that are needed. And then you basically, what we've outlined in these roadmaps is the pathways of the enablers and the technologies, and how the technologies mature as well, to get us to 2050 and to targets that really are about reducing waste, reducing energy, improving sustainability, and keeping and improving the economic leadership of this sector in the UK. So you've got the left-hand zero carbon roadmap, which with zero carbon technologies, obviously they have the largest carbon reduction potential, but also the largest market opportunity for the UK because it's an emerging market. And we think especially liquid hydrogen is important here. So that needs to be accelerated in R&D design and development, which is where those cross-cutting technologies come in and digitalization comes in. The second one with ultra-efficient aircraft, and this is already in progress but needs to be completed and rolled out. And then we've got the cross-cutting enabling technologies. One thing just to highlight now, and I'll come back to it, is that in terms of sustainability and getting to net zero by 2050, both hydrogen, so novel fuels, and sustainable aviation fuels, which I'll explain in a minute, you might have heard of those already, both are needed. So it's not an either or, and sometimes if you look at industry papers and voices, sometimes it's painted as an either or choice. It's not either or, we really do need both in order to get to net zero by 2050, and we need both to scale as quickly as possible. So in terms of those cross-cutting enablers with a bit more of a lens on digitalization, what are those? A lot of those cross-cutting enablers have highlighted the sort of more sustainability enabling ones. All of it really is about enabling the manufacturer, the efficient manufacture, design, manufacture, and operation of aircraft. But if we wanted to summarize some of these technologies, it's really about modeling, design, and simulation. And this is both about both in terms of aircraft systems, so say propulsion or wings, but also in terms of materials, so next generation materials, high performance metallic materials, but also composites are really, really important, because composites are a lot lighter. And again, if an aircraft is lighter, it burns less fuel. So it becomes more efficient, and you also need to produce less fuel. So on a whole life cycle sustainability, from a whole perspective, lighter materials and kind of next generation materials are really critical, as well as cryogenics. So we've done a really interesting project recently, just finished, called Fly Zero, which is about looking at the most carbon reducing future technology options in aerospace, and liquid hydrogen came out on top of that. So not gaseous hydrogen, which we're talking about a lot, but actually liquid hydrogen, because you can condense it more and put more on an aircraft, and so you can fly further. And so with liquid hydrogen, you need to, in order to store it, it needs to be cryogenic. In order to be liquid, it needs to be really, really cold effectively. And so for that as well, we need new materials, new tanks, new thermal systems, and so on. So again, modeling, design, and simulation, both of aircraft systems, but of materials, and all of that can be accelerated and done more effectively and more efficiently using digital technologies. Then it's about the manufacturing itself, so about connecting manufacturing systems, and in a factory, but also outside of a factory, actually digitally connecting supply chains, and ideally more and more towards a whole life cycle, so circular view of from the moment you extract the material to end of life, basically creating digital threads where you can make sure that your production is as efficient, so as little use of energy, as little creation of waste as possible, that you can trace materials and components and products, so that maintenance and operation and repair is supported, and then you can also enable circularity at the end, where you can reuse these materials as much as possible. So here again, digitalization is a huge enabler. And then finally, it's digitally enhanced support, basically in terms of operations. So that can be both on maintenance, repair, and operations of the aircraft, but also flight operations. So using the most efficient, shortest flight routes, and also those that will most avoid contrails, so condensation trails. Interestingly, those are a big kind of unknown, but likely also a big heating factor. So there's a lot of research that still needs to be done. But aircraft, both kerosene burning, but also hydrogen burning, emits water. And depending on what the atmospheric conditions are, that water can condensate and leave trails. And those are warming, short-term warming, as opposed to CO2, which accumulates over decades and centuries, but there's still a warming agent. And so it's really going to be critical to avoid the creation of those condensation trails as much as possible, which we can do with intelligent flight operations. So that's a really brief summary of some of the key areas where we think digitalization can and needs to be an enabler. We're doing on time, a few more minutes. So in terms of how to think about sustainability, the core bit here of this slide is really that we need to think about sustainability from a whole life cycle perspective, and also from different aspects. So emissions are critical, that we address those and look at those at on the next slide. But also we need to think about noise and local air quality and impact on health and well-being of residents. We need to think about materials, both in terms of raw materials, but also use of hazardous materials throughout the life cycle of an aircraft. So when you're doing maintenance and replacing oils and anti-icing fuel liquids and so on. And then waste, both in manufacturing, which on some components can be up to 90% of scrappage during the manufacturing. So improving that, and again using digital technologies where possible to improve, to lower that waste generation, and then also the end of life recycling of aircraft. Another point though to consider here, I'll just jump ahead, is that the absolute vast majority of emissions of an aircraft is generated in operations and not in manufacturing. So while digitalization of manufacturing processes, I think, is a key enabler both in aerospace and in other industries, other manufacturing, it is really critical that we look at emissions and then how to reduce those in operations, because steeply upward of 90%, possibly even 99% of emissions are caused by operations, so by what you're burning when you're flying. That number depends a little bit on sort of what the visibility of life cycle emissions, which is again an interesting area for digitalization and general data collection, which we still need to get better at across all industries, really. So a brief summary of where we are, which is, as I said, around 3.5% of global warming caused by aviation, and how we can get to net zero. I won't dive into the detail for the benefit of my next speaker. But we can talk about it a little bit more. Basically, if we do nothing, the absolute emissions, but also the relative emissions of aerospace and aviation will continue to rise and eat up to close to 10% of the global carbon budget, because demand will also rise and other industries will hopefully decarbonize. So, you know, we are committed to, and we really need to be doing a lot in aerospace as in other industries. And so the top slice of reduction is through ultra efficient technologies that I mentioned. Then the next slice is introducing zero carbon and hydrogen aircraft. Then we can slice off some more emissions through improving operations, and I've talked through that. And then we've got sustainable aviation fuels, with the purple slice being biofuels. So effectively kerosene replacement fuels generated from biological feedstocks, or waste largely at the moment, and in the future also from growing crop. This is a really good sort of short to mid-term solution, because you can mix it in the first place with kerosene fuel. At the moment, it's permitted up to 50%. We hope there'll be certification in the near future to up to 100% of SAF usage. So you can, in effect, replace kerosene to an extent. You are still burning, so this is a life cycle sustainability impact that you're making. So you're burning fuel still and emitting CO2, but because of the way it is manufactured, produced, you've emitted those emissions. You've abated those emissions, or offset those emissions through the production process. It is short to mid-term a sensible solution. The challenge with it is that the biofuels won't scale. So this is why that purple slice isn't getting any bigger, because the bio feedstocks are limited in terms of how much access you can get. So waste will hopefully get less, and then you're getting into land use challenges of how much crop can you actually grow to produce biofuels. So you need to look at something else, which is then largely this turquoise slice at the bottom, synthetic fuels, which are a good solution. The challenge with those is that they require a lot of energy and they require hydrogen, at which point you get into SAFs being an enabler for hydrogen. So you need hydrogen to generate SAFs, but at some point actually it becomes a lot more both environmentally and economically effective to use hydrogen as a fuel rather than using hydrogen to produce a different fuel to then burn. So a lot of detail that I'm happy to discuss with anyone who's more interested, but the bottom line of this is we need a rapid scale up of new types of fuels, both kerosene replacement fuels and hydrogen. So that gray slice at the top, it's not very big by 2050, but it will grow a lot bigger and economically and environmentally more viable post 2050. So we do need to look at sort of longer time scales here as well. And we need a rapid scale up of these fuels, of new types of aircraft and of infrastructure, all of which really requires digitalization. So in summary, some of the key sector challenges are massive speed of transformation. I've already talked through this. Optimizing and speeding up production while minimizing whole life cycle environmental impact. So we want to produce novel aircraft faster. At the moment, production is very slow, and an aircraft stays in service about 25 to 30 years until it gets retired on average. So if we're looking to make an impact, we need to make sure that that cycle gets shorter by speeding up production without making it worse in terms of sustainability. And then, as I said, multiple infrastructure for SAFs and fuels. And digitalization, really needs to be an enabler for that. So speeding up the development, the production, the time of market, reducing energy and waste through more information, more insight, and then also helping to build capability and capacity, as I said, for new materials, new fuels, to really, understand how we can create those in efficient and effective ways. And so interestingly, sustainability and digitalization are sort of both very, very complex systemic challenges and very difficult problems, but also they're both enablers, and they can enable, one can enable the other. They're mutually beneficial, and they have extreme benefits. So while they're both extremely hard to achieve, they have extreme benefits. They're both about removing barriers to exchanging information. So they're about more insight, more information, more data, and then insight to make informed decisions. And just a little cheeky slide at the end. What do we need from regulators? I think we need three things. We need to accelerate. So we need, especially in industries where standards are critical, like aerospace and other industries that people in the room might be working in, new standards are needed quickly. We need to prioritize, I think, in terms of both scarcity of resource, really the people working on it, but in terms of also scarcity of time to take decisions and to make change. I think it's an important thing to accept that we're resource scarce and that we need to prioritize. And so what can be the most effective drivers for change, and to prioritize those first. And then being an enabler, I think regulators can be huge enablers. They're sometimes maybe perceived, as slowing down processes, as kind of gatekeepers, but really they can be enablers where they can signpost and also drive change, because they're critical also for business cases and for sort of looking at business viability and mutual acceptance and even sort of the culture in the sector. So I think that enablement function is really, really important, and that needs to be the approach, I would suggest, needs to be both specific but also flexible, because all of these areas are still in development, and they will change and they will iterate and develop over time. And so a level of flexibility is required. And that's me. Thank you very much. I hope you on some interesting insights, and I'm happy to hand over to David now for I think more cross-cutting perspective on digitalization across industries.
Thank you, Maria. David, hopefully you're there, and over to you.
Thank you. Good morning and afternoon, everyone. Just on 12 there. Thank you to BSI for inviting me to speak to you today. I'm really excited to discuss this. My name is David Pugh, and I'm the Head of Sustainability at Digital Catapult. Digital Catapult is a government-backed innovation centre focused on accelerating the adoption of advanced digital technologies. So those are artificial intelligence, distributed systems such as blockchain, immersive technologies such as AR and VR, 5G, IoT, and increasingly quantum computing. And so the role of the Digital Catapult is to support the UK in adopting these technologies, partly government funded, partly funded by industry as well. And the reason we exist is that the UK has a huge and really successful wealth of digital experience. From the Digital Futures Index that was published at the end of last year, the UK ranks first in Europe and third globally for digital technologies. And if we take a look at some of those digital technologies that I mentioned there, we are kind of second and third, so in the medal positions for most of the, well, for all of the technologies that the UK is kind of really working on. And the role of the Digital Catapult is to take that technology expertise and to accelerate that and take that technology to industry, to break down barriers, to de-risk innovation, to open up new markets, as well as supporting that technology expertise in growing and working with UK companies. And our aim really is to responsibly and sustainably shape the products, services, and experiences of the future. Now, where sustainability intersects with that is a very interesting role and a very key role for the UK. And I just want to start by defining really what sustainability is. And sustainability is creating value for three key stakeholders: the environment, and that refers to really the air we breathe, the water we drink, the soil we use, and the energy we consume. Society, and that's referring to safe and valuable work for people and interactions among individuals and groups. And the economy, so that's profit creation and efficient allocation of scarce resources. And over the last 200 years, we've really focused on creating value for the economy, and often at the expense of the environment and as society. And there are so many opportunities to create shared value for all three of these stakeholders, and industry and globally, people are starting to recognize this, that we can't keep making endless money. That's fantastic, but for what reasons? And so creating value for these three key groups is really important, and that's why the work that we do at the Caspar, every project we do, we have to assess where value is being created. And there's a growing trend, especially in the innovation space, looking at something called a twin transition, and that is the transition to a digital economy and the transition to a green economy should go hand in hand. Now, this isn't a term that I've come up with, or Digital Caspar. This is from the European Commission, and essentially the best case studies that you're finding today around sustainability are where companies are aligning their technology and their sustainability strategies and aligning them and pushing them forward together. And there's a fantastic report, which is where we got these stats from by Accenture, called the European Develop. I'm happy to send you a copy of this report. And this found that companies that are aligning their digital and sustainability strategies are creating value for all three key groups, and they're 2.5 more times as likely to have strong performance over the next decade than those that do not. So for success over the next 10 years, 20 years, real future success really comes from transitioning to a digital and a sustainable economy. And the reasons for this are really that the reasons we utilize digital technologies are to become more optimized, transparent, resource efficient, resilient, and so on and so on. And the outcomes that we get from using digital technology are the underlying things we need to do as a society and as industries to effectively tackle climate change, effectively become more sustainable, to create value for society as well. And so the two areas go absolutely hand in hand. Now, the work that Digital Caspar does, where we find that there's the most impact to be made in sustainability, are in these three areas that make this terrible acronym of SEED. So the circular economy. Now, this is the idea that linear economy, well, not the idea, the fact that linear economies and linear supply chains are always pushing towards end of life. Products are used either by a single user or even just a single time. And so we're looking at how do we repair, reuse, remanufacture, or recycle products to prevent us having to mine for new materials, to grow new cotton, to create new silicon. How can we effectively enter a circular economy? And part of this is through data-enabled business models. One of the best examples in this space is Rolls-Royce. I'm sure you're very aware of Rolls-Royce's Power by the Hour business model, where instead of selling aircraft engines to the likes of British Airways, they provide those for very, very low cost, in most cases for free, and then they charge based on how long those engines are in the air. And so the responsibility for keeping your aircraft engine working at 100% with high utility, all single lasting, really doesn't sit with the product user anymore. It sits with the manufacturer. It's on Rolls-Royce to ensure that their engines are working at full capacity, because if they don't, they're not getting paid. And what this has led to is Rolls-Royce having their engines completely kitted out with sensors, sending data all the time to control centers. And then if something is going wrong, if a fault is detected, either software updates can be sent to the engine to ensure that this process is fixed, and we can only go for software or firmware over the air updates, or when the plane lands, there's a team of engineers ready to understand what's gone wrong, fix it, get that engine back up in the air as soon as possible. And this works very well for aircraft engines. And it can be applied to a whole host of industrial assets where we can be charging per meter of material rolled or per hour of usage. And what that does is it means that we're extending asset lifetimes. We're not throwing away as much. As well as those new business models, there's a lot of digital infrastructure that needs to exist to enable a circular economy, ensuring that products can get back to source to be remanufactured, repaired, etc. Ensuring that there's an understanding of what's going on with a product during its lifetime. All of the success of a circular economy really depends on how data is transferred and shared between the multiple owners an asset will have during its lifetime. Second piece is around energy. Now, Maria spoke very well on kind of hydrogen and the future of hydrogen and liquid hydrogen. Hydrogen is one of the fuels that will power the future, but then we've also got solar and wind and hydro energy, and all of these different energy sources contributing to providing the UK and the globe with a reliable source of power constantly is going to be incredibly important. It's something that digital technologies can automate and manage. We're also looking to accelerate the production of clean energy. We've got a great offshore wind economy in the UK. How do we ensure that we're able to roll out solar and hydrogen production facilities? How do we look at small nuclear reactors, and how do we ensure that the data around those is shared with all the right stakeholders so that people have access to the right data at the right time? And finally, we're looking at decarbonising supply chains. So optimizing individual manufacturing processes, and that could be through predictive maintenance to reduce downtime. It could be through increasing yields by utilizing artificial intelligence. It could be improving schedules so that we're able to produce the same amount of material with less effort and less feedstock materials. Also, efficient carbon measurement and accounting is actually, it should be very simple to know the emissions of every product we buy. It's actually very difficult because there are so many steps in the supply chain and companies only report on their carbon measurements once or twice a year. And so we're constantly looking back, whereas using digital technologies, we could be collecting this information in real time. We could be using digital systems to ensure the flow of data goes with products. And so when it comes to an OEM manufacturing a car or a boat or a plane or a laptop, they have all the data about where these materials came from. Were people treated fairly during the extraction and production processes that went on in the supply chain? What are those emissions? And then OEMs can look at their suppliers, and every tier of the supply chain can look at its suppliers and say, is our supply chain doing its best to think about the three key stakeholders, being the environment, society, and the economy, and make the right choices. And finally, implementing the right incentives. It's very easy for a large multinational company to commit to sustainability and to bring in innovation programs, but it gets much harder the further down the supply chain you go because those companies become smaller, margins become lower. So how do we implement the right incentives to ensure that not just one node in the supply chain pushes towards net zero, towards sustainability, but how do we put the right incentives to help the entire supply chain get to net zero? I'd just like to go a little bit deeper on some of these examples and share with you a few case studies of work that we've done and how we've seen that digital technology is really making an impact. And so if we want to extend a product's lifetime, we need to understand what it's doing when it's out in the field. And so connected products are a brilliant example of how to keep products in use for longer. By implementing some sensors into a product, by understanding what it's doing when it's like that, understanding also any indication that the product is struggling or that a particular part in that product is struggling, helps to repair it early and keep it going longer before that becomes a bigger issue. Connecting products gives us a better understanding of performance. It can help us improve design in the future as well as those manufacturing processes. There's a whole host of new revenue streams through servitized business models, much like Rolls-Royce, the Rolls-Royce example I gave earlier, and new value from partnerships by combining data from multiple sources to deliver real value. If we think about things like Amazon Alexa, where Amazon do not own every device that has an Alexa chip in it, but they built an ecosystem where by lots of different data sources coming together, they can provide collectively a service to you as a consumer and a home owner, or someone who lives in a home, and can really help to automate different aspects of what you're doing. The same thing is true of industrial assets. If we're able to combine data from multiple industrial assets, we can collectively become greater than the sum of our parts. And then finally, the standard, we often talk about this in digitalization, but remote monitoring for maintenance. How do we ensure we fix something before it breaks down and creates excess downtime? And these are all really good examples of how data is being used today to extend asset lifetimes. Now, in the supply chain side, this is a project that Catapult Deliver are about to finish. It's had real impact. And this is a project called the Digital Sandwich. Now, you may remember a few years ago that the NHS had a real challenge and a public crisis around E. coli in sandwiches for people, in hospital or visiting the hospital. There was an E. coli outbreak, and because there was not a good record of the supply chain of these sandwiches, there was no way to tell whether a sandwich had an E. coli problem or didn't without actually testing it. And so as a result, millions of pounds of food was thrown away, and a huge amount of food waste, financial impact, and reputational damage took place. So we began a project about just over 2 years ago now to look at how do we improve this supply chain transparency and traceability. And so by working with Rainers, who are the sandwich manufacturer, and their supply chain, so looking at where the wheat comes from, where the bread comes from, where bacon, lettuce, tomatoes, every aspect of the sandwich, and starting to collect data at the source and using IoT platforms to record, curate, and deliver supply chain data in real time, and put that data into a distributed system to provide immutable food traceability, as well as new contracting methods that benefits the entire supply chain, and then AI to optimize that supply chain inventory. Means that when a sandwich is made and it's in your hands, you could track that back to this lettuce came from this farm on this date. And touch wood, we won't ever have an E. coli outbreak in the NHS again, but these things happen. If something did happen, they'll be able to get 100% insurance around the validation and verification that the sandwiches that are being consumed have not come into contact with those batches. In addition, we've also seen a 10% reduction in waste across the supply chain and a 10% increase in productivity. So the adoption of digital technology has much more than one benefit. Sustainability is one of the outcomes of using digital technology, but we're also going to see financial improvements, air quality improvements in factories, lots of other benefits to adopting these technologies. And then the last case that we'll talk about today before we jump into some questions is around a tool called the Ecometer. Now, as I mentioned, actually collecting data on your carbon footprint is typically a retrospective process. It's all about looking back. Digital Catapult is just completing its own carbon assessment, footprint assessment on the activities we do and the offices we hold. It's very much looking at your energy bills, looking at how much you spend with cloud providers, where you source your materials from. So everything is done in retrospect. And for a manufacturing company that produce millions of batches of product a year, it doesn't really give a customer a good understanding of what were the emissions of producing this batch of material. And so we've developed a tool called the Ecometer that's now deployed in a few different companies, where we're able to access information through energy meters and through material usage and through a few other pieces that puts together a close to real-time carbon footprint measurement. So it's measuring every 15 minutes the material usage and the energy usage and a few other pieces, as I said, to give essentially batch-to-batch footprint information. And this is really great from a supply chain perspective, because it means the companies are able to tell their customers, you've bought this batch of chemicals, for example, and the carbon footprint associated with this batch is this much. So at point of purchase, at point of delivery, they're able to have that information. The company is also then able to look at, okay, well, what is our batch-to-batch variation? In theory, everything should be, plus or minus 2%. But we're seeing on a Thursday, 25% increase in the carbon footprint. Why is that? Or on weekends, or in the summer or winter, and understand what is an acceptable variation, and then where are we missing out on reducing our carbon footprint? And in addition to our carbon footprint, where are we paying too much for energy? Where are we taking longer or getting lower yields than we would expect? And using that information to make informed decisions about how to undertake continuous improvement in the factory is incredibly valuable for those organizations. So in conclusion, the UK has a wealth of technology experience, and Digital Caterpillar exists to help industry benefit from this. There are many thousands of companies that could be helping industry right now, and it's our job to make sure that the best technologies get to the right people, that technology is used for real problems and challenges. It's not just technology for technology's sake. Now, digital technology plays a key role in enabling sustainability. Making industry more optimized and resilient will have direct implications for the emissions and waste of an organization, as well as great cost savings in terms of energy, in terms of increased yields, in terms of worker satisfaction. And companies that are aligning their technology strategy and their sustainability strategies today are setting themselves up for success over the next decade. So thank you for your time today. I'll hand back to David. It's been great to speak to you this morning.
Thank you, David, much appreciated. Can we just pop our cameras back on? That's okay, for a moment.
Yes, won't be a second. There we go.
Brilliant. Thank you, guys. Very, very insightful, and hopefully it will give our audience a little bit of some food for thought on what is a very complicated subject matter. But they were great presentations, and thank you very much. I'm going to leap straight into some of these questions. And I'm going to give David 2 minutes to get his breath and fire a question at Maria, if I may. Because there's a question on the floor, and I think, Maria, you did touch on this, around sort of liquid hydrogen, nitrogen in aviation, and, kind of how do we keep the energy requirements? I guess the question really is related to ensuring that we're kind of not applying one methodology, but at the same time impacting somewhere else. So, for example, you mentioned biofuel, and that has an impact on farming, and then on liquid nitrogen, the kind of energy requirements to keep the nitrogen at the required temperature, and whether you kind of have any thoughts on that, because it's going to be quite challenging things to address, I think.
Yeah, definitely. This is a really good question. So it's a question around whole life cycle sustainability assessments, and whether you're not making one thing worse, fixing a problem over here, but actually making it way worse over there, which is, I think, one of the absolutely key questions in any decarbonization and sustainability focused transformation. It is a difficult question because it relies on a lot of research and a lot of data that is partially available and partially not yet, and is being done. And I think this applies to aviation as to many other sectors. So I think some of the things that David also mentioned around, really finding out when are you using this much and that much, and what are the right times. And so it's a systemic view that we need to take. Absolutely, I agree with the person asking the question. And we're, as the ATI, doing a lot of research in terms of making sure that the assessments happen at a systemic level, and that we're also pointing out where there are uncertainties in our knowledge. So I'll get to the specific point, but another critical example of this is the condensation trail formation, as I mentioned. So it will be challenging if we realize that actually we've got massive impacts on contrails that are also warming, that hydrogen might not address, because unless you capture, you have no emissions, as in you close the pipe because you have fuel cells and you capture the water, you're still emitting water at the very least. The point with this is that actually there isn't full visibility, neither at the moment in terms of kerosene burning and when exactly contrails form and how you can avoid them. This is the case for the current situation as well as it is still the case for hydrogen. So we're absolutely working with EPSRC and NERC and universities and generally just kind of pushing the agenda to say we need to sort out this climate research. Which is, big data, systems level, difficult. David will know about this being a chemist, research. And so, yes, that needs to be addressed. In terms of hydrogen and the kind of upstream, I guess, from hydrogen requirements. So if you look at it at a systemic level, and this again applies to aviation as any other industry talking about hydrogen, whether liquid or gaseous doesn't make a difference in this case. It requires a lot of energy to produce hydrogen. And that energy needs to be green or at least low carbon. You can think about nuclear. There are other kind of, if you know the kind of color scale of hydrogen, there are various options that you may have various opinions on, but basically they need to be low carbon or zero carbon in order for it to make sense. Which puts a huge requirement on the deployment of energy producing infrastructure, whether it's wind, solar, water, any, or nuclear. And so there is definitely an upstream impact and an upstream requirement that we need to look at, because you can make things worse if you say, yeah, we all need to use hydrogen. There isn't enough green hydrogen, so let's just use gray hydrogen, which is effectively fossil produced hydrogen that is not going to help the bigger picture if you're actually trying to fix the problem rather than kick the ball into the weeds. So yeah, overall, I think a systems level view is really important. It is not without its challenges, because we, I think, as humanity are still learning, and as individual industries still learning to really get into the weeds with the data and with the knowledge to produce those insights. And something like on the smaller scale, like the, what was it called? The Eco tool that you mentioned at the end, that's a really good start to start thinking about things like that and then scale this up.
How far away do you think are we to being fully electric? And do you think that's the answer?
I think it's all everything is a partial answer. There is, unfortunately, if there were a silver bullet, maybe we would have found it already or used it already. There isn't. It is kind of partial solutions and roadmaps and incremental improvements and transformational improvements. Electrification, I think, is an important part of the puzzle. Absolutely. I think it's also important to consider that where we have electrification solutions, as much as upstream they might have other, impacts in terms of mining and so on, but where we have decarbonization solutions, we should probably not be using hydrogen, because the need for hydrogen across industries is going to be huge, and there just won't be in the foreseeable future enough hydrogen for applications that are harder to decarbonize, which is aviation, but also, for example, steel production. Some industries have a harder time decarbonizing than others, just because there aren't enough options. And so in that respect, electrification is critical where it's possible. If you're asking about flight specifically, it's a solution for sort of sub-regional and regional, so short distances. Unfortunately, we run into physics problems if you're trying to fly faster, because batteries are very heavy, and at some point the weight that pulls you down versus the energy that you need to actually lift off, it doesn't add up anymore. So it's not a solution, and we don't see a roadmap either in terms of battery development that it will be in the foreseeable possible to solve that physics problem. So you need something that is more dense and lighter in order for it to work for longer sort of mid-haul to long-haul flight.
And as you say, producing batteries has a knock-on effect, on sustainability and net zero. Just the pure production of huge amounts of battery requirements, takes up a huge amount of resource. That again, it's kind of a check and balance thing, isn't it?
It is. I mean, not everything we do has an effect. I think, we kind of need to, I don't know whether waking up, but just accepting that everything we do has an effect. The only thing that doesn't have an effect is if we don't do. But if we don't do anything, then we're staying on a pathway that isn't working either. So it is, again, a very complex question, but we need to get as much data, as much insight in order to make informed decisions so that we take, and we have a small time window for that as well, to put the right levers in place and to take the right decisions. So we need to be pushing, and I think, you know, everyone in our individual businesses and industries need to be pushing for thorough data and thorough insight, and not just kind of top level solutions that maybe sort something out in the short term but don't actually make a long-term difference. I think it's on all of us, and also as consumers, to be honest, to really kind of peel back the layers as much as we can. If we're those people who are looking for insight and information, then I think we all have that responsibility and opportunity to ask those questions and try as hard as we can to drive towards the right solutions, even if it's, you know, a complex playing field.
Brilliant, thanks, Maria. Any comments from you, David, or shall I challenge you with another question?
I was just going to add, I think Maria is absolutely right. There's no silver bullet, especially for energy, and it's about not by thinking hydrogen is going to replace oil and gas, or you know, wind power is going to replace oil and gas. Nothing's going to replace oil and gas, because oil and gas is a very versatile fuel. But what you can do is understand what's the right fuel to use for the right application at the right time, and how do we do things a bit differently. There's nothing wrong with doing things a bit differently. It's a bit scary, but we can't, like, by bringing in these multiple forms of energy, it brings us flexibility, but also energy security. If we're not reliant on a source of energy from a different country, which may or may not be under some sort of sanctions at the moment, then it gives us not only the environmental impacts, but that societal piece of there, we don't have to worry about rising fuel prices in the same way because of geopolitical events. And so understanding that we're going to have a number of different fuel sources, and that's okay, and that we're going to manage them a bit differently, and that's also okay, is really important for the next 10 years, because this is something that will happen.
Yeah, thank you, David. I guess yeah, none of this is going to come without its challenges. This is enormously complex, and is going to take, you know, almost a complete transformation of different sectors, you know, transport, energy, consumption, goods and services. Thankfully, obviously, there seems to be a political will and a consensus to kind of reach these targets. But I was kind of interested on both your collective thoughts on kind of what would you say is the biggest challenges, kind of one or two top challenges that we need to address to kind of achieve this ambition of net zero by 2050, and also then perhaps thinking about the perspective of individual industries. You know, there's kind of going to be cross-sectoral challenges, but are there specific industries that are going to need you know, specific focus or specific areas to address those challenges? David, perhaps you can give us your thoughts on that.
Yeah, I think the most important thing really is collaboration. No one's getting there on their own. Either everyone gets there, or it's speaking about net zero specifically, either we all get to net zero or none of us do. And so we all need to be moving, even if that's down to just a supply chain, we all need to be moving in the same direction. And so individual companies saying, we're going to do this in isolation over here, leave us alone, is not the way that we either kind of get there digitally or from a sustainability standpoint. So collaboration with the right organizations that are directly working as part of your ecosystem is so key. We've started to see a lot of movement in consumer-facing industries. Food is doing a lot more. The food industry is doing a lot more to think about its environmental footprint. How do you look at things like the logistics sector as well, who are transporting vast amounts of food or medicines that need to be stored at the right temperature in transit and can only go in certain routes. And so they're looking at how do they do that in a more sustainable way. Energy-intensive industries, so chemicals, steel, cement, it's a real challenge for, because these industries, there's been lots of offshoring, especially in the UK over the past 10-15 years. They require reactors to be set to high temperatures, and there's no way to do that. There hasn't been a way to do that cheaply without natural gas for a long time. And so it's really bringing in, how do we disrupt what is a continuous process and may have been moving for the last 20 years. If you think about sheet glass tunnels are turned on and they run for 20 years continuously. So there's a lot of legacy equipment that needs to be upgraded or retrofitted, which is a huge challenge, especially when you've got business as usual. But collaborating with the right partners that can bring in that expertise. It means you don't have to start from zero and do it all yourself, but people with that expertise, your supply chain partners, to collectively push in the same general direction to net zero is incredibly important.
Maria, any thoughts from you?
Yeah, definitely. I very much agree with David around collaboration. I put down kind of 3 key thoughts, one of which was that it takes all of us, and we're also, I think, we're not getting there automatically. So as much as there's, you know, political buy-in and business buy-in, and there are roadmaps that like the ones that I presented, and like, you know, other industries that will have, they are not automatically happening. They are happening with a huge commitment and focus and investment, and you know, all of us driving those and all of us asking those questions, because there need to be enablers in place, like a lot more renewable energy technologies that haven't been developed yet, or that haven't been developed at scale, implemented at scale yet. So it takes all of us, and it takes all of us to push for it, I think. And linked with that, it takes, I think, and we're moving into this, into a different way of thinking about business cases. So David alluded to it a little bit in terms of what does sustainability mean, you know, profit, planet, and people. We're still in a kind of frame of mind, you know, I don't know, generally, culturally, however big you want to pull the scope or draw the scope, but of business cases thinking about profit and everything else being kind of additional, you know, intangible benefits or something. But there is a growing voice of even also people from the finance sector, investors and so on, who are starting to think about business cases as integrated business cases, and saying it only stacks up if it makes sense across profit, yes, people, and planet. And so asking and pushing for it together maybe gets a little bit easier if we start thinking about business cases in this framework, and starting to feel like it's not a dirty question to ask, but what about sustainability here, and, you know, how can we be doing more? Because I think in some cultures and some environments, people might still feel like they're being very, you know, I don't know, revolutionary and challenging if they ask their questions. But I think we need to start realizing that there are also huge business opportunities in there. You know, there are new economies emerging, as David said, the dual transformation of kind of green and digital. But also, if it doesn't work on a planet level, then it's a very, very short-termist business view. It will not work midterm for any business, profit-focused business case either. So that can be an enabler. And then finally, I think trying to identify the bigger levers and focusing on those, because something that I've kind of experienced trying all kinds of or working on all kinds of different sustainability transformations is there's a risk that we get lost in detail, because there is so much information and so many aspects that you could start working on, and that goes from whether you're trying to make your home more sustainable, or your business, or an industry. I think it applies to all of them, and really looking at where are the big levers, what makes the big difference, and let's, you know, also do the smaller things, but be aware that some of the smaller things will have a smaller impact. And so again, accept it's constrained, and that we have to prioritize. And one, you know, just random, not random, one example of different sphere, but it's just to say, I think this approach applies to anything that we're looking at, whether it's industrial applications or pension funds. So pension funds are a huge lever in terms of where our money is what our money is contributing to. And I think it's a bigger lever than many of us will appreciate, and it's very difficult to get the data. So I'm doing this exercise right now, and happy to share it. But it's very difficult because it's not digitally enabled, and there's no digital kind of you know, traceable trail of exactly this is where my money goes. It's very manual, but it is a big lever. And so identifying what are those big levers for your industry, for your business, and what can you do to make sure that you're headed in the right direction in terms of sustainability, prioritizing.
Because collaboration is quite hard. Bringing people together can be quite difficult in solving these challenges. I think all 3 of us are involved in some level or another in trying to convene communities to problem solve and deliver on these kind of major impacts. I guess the question I had was do we think there are incentives that could be applied in supply chains might make a difference? David, your views?
Yeah, I think so. There's this concept called insetting, essentially, where at the moment, big corporations are putting a lot of money into planting trees, which is good, not from a carbon emissions perspective, because trees don't absorb that much carbon, but from a biodiversity, lowering the water table, etc. But what if that money was instead put into investing in their own supply chains, investing in, okay, we know that we need to have this digital infrastructure that sits across our supply chain, and realistically, our tier 2 and tier 3 suppliers can't afford to do that. So we, as a big multinational OEM that has the money to offset, could be investing in our supply chain to make our supply chain more sustainable, to support the companies that we rely on and that rely on us, to essentially move forward together, as opposed to each company having their own sustainability strategy in isolation. Like, there really is a requirement for support. You know, no one's getting there on their own, as I said earlier. So it's insetting, I think, is really the future. I think we'll see more and more of this over the next 10 years. Or large companies and people creating products that produce a large amount of emissions have a responsibility to support the people that are helping them create those, to create those in a more efficient way, and to think about those 3 key levers.
Do you think there's more government could be doing in terms of sort of regulatory policy interventions?
I think there is, and I think to be honest, I think there always will be. COP26, the kind of the agreements we came to were still 10 years behind a lot of what industry's already doing. So I think we will see increased reporting regulations. I think we will see more regulations, but I think industry will be the leader in this space, and that will be driven by consumer behavior as well.
Do you think there's more governments could be doing in terms of raising the bar of the importance of this for society and humanity? I guess we all kind of think it's about saving the planet, which obviously is vitally important, but actually the planet will probably survive us. So it's actually probably more about saving humanity than the planet itself. Do you think we need to kind of up the game for people to raise the awareness?
So I speak to people every day about sustainability, and lots of them say to me, David, I read about this and I get a few pages in, I have to stop because I get scared. And I completely understand that. It's like me watching football on Saturday. I'm terrified that we're going to let a goal in. But I think that there's a lot of the messaging that is potentially wrong, that we see sustainability as a challenge or a problem, and it's not. It's an opportunity to do things better than we've done in the past, to do things in a cleaner way, to create more livable environments, to lower the carbon impact. But also, by lowering the carbon impact, you're lowering the cost imperatives, you're being able to redistribute wealth. There's all of these other factors that come alongside sustainability. So I think it's not necessarily about saving, but it's about improving it, doing things differently to things that we've done before. Because what the Industrial Revolution as being great, but if any of us were alive in the Industrial Revolution, we probably would have thought it was a bit rubbish, if we're being honest. So it's, well, how can we go for this next Industrial Revolution that is a clean Industrial Revolution that actually improves the way we manufacture, the way we move, the way we transport things, that creates value for everyone.
Any thoughts from you, Maria?
No, I very much agree. I very much agree with the perspective, looking at, there is a positive revolution, industrial revolution in front of us. And we need to look at it this way. I think it does come with the insight that there is no scenario in which we can keep going as we are, unless we are not interested in anyone other than our own generation. So, this is, I think, recognized fact by scientists and governments across the world. So if we just accept that there is no scenario in which we can keep going as we are, then we can make it. I don't remember who said it, but I think crisis, I always like the saying, crisis is also an opportunity. And it is a crisis, but it is also a huge opportunity. And I think accepting that and kind of, adulting up to that, to say, yes, it is scary, and yes, it looks like it's not going very well at the moment, but we are immensely capable. We have huge capabilities in this country and in other countries, both technologically, scientifically, and everything that we said previously, right? We need to collaborate, and we all need to be pushing in that direction, and be pushing for more data, more information, more insight, to understand which direction we're headed and how we can influence it to get more sustainable.
Crisis creates focus, doesn't it? So there's a question here around how do we design for sustainability? I'm interested in the panel's thoughts on, is there any guidance on steps that organizations should take? David.
Yeah, so there's a couple of things. So firstly, there's how do we design for things to be in life longer? If we think about a circular economy, then I think a great circular economy example is bikes. Now, we all might own bikes that we maybe take out on the weekend, or we cycle to work, or we cycle somewhere. But we cycle for 20 minutes, and then the bike is chained up somewhere for hours and hours. Now, we've seen this growth in bike sharing, and if you live in a big city, you probably have the bikes that connect into the little locky things that you pay per mile. And those bikes, they're not as slick as a brand new rally bike. They're not as light, they're heavier, they're bulkier, but they will last a lot longer than my bike. And during that lifetime, they'll be cycled by a lot more people, they'll go a lot more miles. And so creating things to be more robust, they don't need to be aesthetically as good or go as fast, but they serve their purpose very well. The other piece is around having kind of standard connectors, and especially for large pieces of industrial equipment. I've just got a new laptop today, and now I have that are completely different. So this one's going to have to be thrown away now because I don't have a laptop that it works with. It doesn't work with my new one. So that's a very simple example. But if we think about ships and planes, that if an aircraft wing falls off after many years, hopefully when it's on the ground, it needs to be replaced, the likelihood is that there's been obsolescence and the connectors have gone out of service, and so you can't necessarily fix it. So having standard connectors, standard ways of replacing assets means that we can look at things in a circular economy, and we can replace individual parts very easily. We can fix parts that are broken using a lot of standardized connectors. Now, there is regulation coming in this in electronics, and hopefully this will come in other areas, but this is how we design for a circular economy where things are easier to repair and replace on like an individual parts level. In terms of designing, it's very much like looking at your portfolio of suppliers. We're working with a couple of companies at the minute looking at how a detergents company, for example, saying we have thousands of suppliers that supply all different parts, but we can't make a decision on who's the best necessarily because we don't have the information in front of us to say, well, this material comes from this country, but they're using a much more sustainable production process. And how do you make the right decisions there? It's all about having the right data in front of you to make those informed decisions about where your parts are coming from. Sorry, I hold the conversation there, but I think Maria probably has a lot to add.
Maria?
Yeah, I think the principle applies, what you said in terms of you could call it interoperability as well, right? So that the same applies to data, because a lot of the challenges with digitalization are that data formats are different. Data is stored and tagged in different ways, and you can't kind of merge it, and so you can't actually get insight, you can't analyze it. Systems are not interoperable, so you've got sort of one software doing one thing and another software doing another thing, but they won't actually work together. So it applies to the digital world as well. And I think I was thinking about other areas, materials as well. So one of the challenges, I said that about 85% of planes are already recycled. The challenge is composite materials, and that applies to any area of manufacturing as well as to your bin at home. Is the stuff where we stick different things together that you can't disaggregate easily. Then that makes it harder. And so I think taking this kind of more standardized components from a materials level all the way, well, from a data and then materials level all the way to large parts. Overall, that's a very good direction, I think, to think.
Both of you touched a bit on this, but we can't get away without asking the question around standards when you're on a panel in BSI, and the question really is, what role do the panel see standards playing in the transition to net zero? I think you've kind of answered that question, particularly around kind of interoperability and data. But I guess the question is from me to you is, what more can we do as the UK's national standards body and the kind of global standards organisation to support, I guess, the accelerated development and adoption of standards? Any kind of thoughts on that?
If I may jump in, for me, I think the prioritization is really important, because which standards, so how many standards do you produce in a year? How many standards are you able to push out? And can we assess which standards will make a bigger difference and prioritize those? So not less, but not getting lost in the noise, which I think is for this whole sustainability topic a critical thing, again, in terms of levers and so on. I think collaborating with industry, many of the themes that we've already mentioned, I think come to mind here. And then thinking about where the standards can also be industry drivers, and I think that's something that you're already very much doing. But where do you think, rather than trailing, I guess, leading and saying, I don't know, as an example, in terms of workplace safety, handling of hydrogen is huge. You're probably already working on this, but where can standards bodies at large, standards bodies and regulators be leading and nudging and working with industry to put those themes on the table and say, what needs to happen. And the only other point I would say is, that's a tricky one probably in regulation, but is there a way to think about standards in a more agile way and say, well, we don't need to define the whole way through because we can't at the moment yet, and if we do, it might actually become a blocker. But we can define maybe at a high level to say, this is important and this needs to be regulated, and here's sort of a light touch standard or a direction, and then you go into more detail as the technologies, the fuels, everything develops, because there's a lot in this transformation that is still developing. And so I think taking this more iterative approach would also be an enabler.
David, thoughts from you?
I think Maria is absolutely right. With sustainability, what's really exciting is that there is this much you can do. You can be doing everything around sustainability, but that's also very daunting because we can't all apply our skills directly into every challenge. So it's understanding where the biggest imperatives are today and focusing on those this year, and then working down a prioritized list. So understand where are standards required. And second is about getting the information, and standards are understandably very complex, and getting the information into the hands of people in factories, people in logistics, people in supermarkets, so that they can understand and implement them as quickly as possible. Because what we really want is, there's lots of great work going on at an innovation level, and it's things that are starting. We need to get those things scaled up as quickly as possible, and that means getting people educated, getting people using the tools, the standards, the digital ideas at scale in the real world as soon as possible.
Do you think clearly we're going to be moving soon to a world where standards themselves are digitalized? Currently we're kind of consuming and developing standards in sort of PDF format, sort of XML, but we can see a world rapidly coming where actually those standards will become embedded endemically in the systems, tools, processes we're developing. Do you think that will have an impact on how those standards are developed, applied, and implemented, and how we can use digitally to rapidly adopt those standards, including regulation and policy, I guess, as well?
I think so. There's a concept called zero knowledge proof, which is where I don't necessarily need to know how you did it. I just need to know that you abide. So as an example, as a 17-year-old, you go to a bar, and to get in, as an 18-year-old, sorry, you go to a bar, you need to show someone your driving license, and that proves your date of birth. It also has your address on, your full name, and there's a lot of information you don't necessarily want to give to someone you've never met. So the same thing might be true of standards. In terms of ensuring someone applies to a standard, we don't need to know all of the background of all the things that we put in place. I just need to know that they have met that standard, and that automating that process so that a regulator can say, okay, I can see that digital catapult is abiding by this standard, thumbs up, go ahead. I think that's a really key piece for kind of standards in the future. not necessarily having to go through all the documentation to prove it, but having an independent body has assessed it, we're good to go, let's move along more agile, is part of the future, I think, of standards.
Maria, any thoughts from you?
I was just going to add to this sort of more, it's taking a lot from, you know, digital development, MVPs, minimum viable product, and what's your kind of minimum viable way of doing this, and thinking more agile and so on. I had one thought, which is collaboration among standards bodies. I don't know, you know, honestly, to what extent this is happening, but obviously we deal a lot with the CAA, and the CAA have just launched recently sandpits, innovation sandpits, where they're trying to, you know, kind of test and trial new standards and develop new standards with industry and take this more agile approach, but even working on those and, you know, improving those and looking at just close collaboration both between standards and regulators, but also with industry, to be as close to kind of the heartbeat of the pulse of what's happening, but also leading and nudging and challenging industry, I think.
I think taking the kind of approach of the kind of digital sandbox for testing standards, policy and regulation is definitely a way to go, and it's something that we at BSI are exploring in the area of AI. For example, we recently launched the AI Standards Hub with Alan Turing Institute and NPL, and part of that thinking and collaborating internationally is around, you know, how do we take some of the learnings from the financial services sector, where we can kind of take standards and put them into a sandbox environment, look at sort of things like conformity assessments and test them almost in real time, is kind of definitely a way to go. So just slightly changing the tact here, there's a question here around, are there unintended consequences in a rush to decarbonize? David, any thoughts on that? Where might we get it wrong?
It's a good point, and that we see lots of stories. I'll go back to planting trees, and people trying to plant as many trees as possible anywhere, and we're finding that actually you're doing a lot of damage to the wildlife. Those areas, because you're planting trees that do not typically grow naturally in those areas, and you're challenging biodiversity. There's often kind of thoughts to automate everything and kind of cut jobs as a not just in sustainability in general, in economic times, and then that leads to challenges we're having with the aircraft industry at the moment. We haven't touched on it, but there's also the footprint of digital technology. Now, digital technology can do a good lot to decarbonize other industries, but in and of itself needs to look at its own carbon footprint. How are we powering data centers? How are we recycling, you know, phones or other electronics equipment? And so the digital sector needs to decarbonize along with everyone else. So it's important to take a systems level view. We are all going to decarbonize. Essentially, there's no sensible alternative. You know, it's not just the environment, but all of the other benefits that go with it. So these things will happen, but it's important to consider that we're not, you know, plugging one gap here and another gap is opening up over there. And it's important to take a systems approach, understand what's being implemented, what the impacts are on society, on the environment, and on your economy, and make the right decision that benefits all three in the best way.
Agreed. Yeah, I would add to this, if you can look first what you cannot do before you start looking at what you can do. So cutting energy, you know, optimizing production, not using resources, basically, in short, where can you not use resources, is generally, I guess, you know, maybe jobs, as you said, David, need to be considered as well. But generally, the direction of using less resources is definitely positive, and I don't think there's anything that can be rushed too much in there. If you try to analyze how you can use less energy, produce less waste, buy fewer things, and just lower your carbon footprint. I think where it comes to then doing something else instead, so you know, in my industry, using hydrogen instead of kerosene, or even using sustainable aviations instead of kerosene. Yes, there needs to be thorough research to make sure that it's not, you know, a hype, and that you look at, well, you know, it's better on this end, but it's actually worse on the other. There's a lovely German term, you might here that I have some of a German background, but it's called Verschlimmbessern, which means you make it worse and better at the same time. And we're trying to do something better, but actually you made it worse while doing that. And in the lovely language that German is, you can put it all in one word. But yeah, so you need very thorough research and decision making to make sure that you don't do that. I guess when you're rushed, yeah, that's a challenge, but it's also a question of what is rushed, right? So no decision making is usually solid if it's too rushed, but the fact remains that we have very short timelines to take decisions. So example, again, aerospace, in order to get new aircraft into market anytime before 2050, we've got around 5 years or so to actually define where we're going to put the investment and what kind of new aircraft we're going to be designing. If you're looking at it earlier, we were hoping for first hydrogen aircraft, or we would suggest first hydrogen aircraft in the mid-2030s. The development needs to start within the next 2 years. So the timeframes are incredibly short, and I think that is the same or similar for many other industries. So we do need to be clear that our timelines are short, but we need to start, I think, with not doing things that we can avoid, and then assess really well what we're doing instead.
There's another phrase, greenwashing. I don't know how you would say that in German, but that's another phrase you often.
I don't know.
Often
I haven't lived in the country for a long time.
Yeah.
Definitely. Yeah.
We've just got a couple of minutes left before we need to close, and I just kind of there is a question here about the kind of, I guess, bringing us up to the current situation of geopolitical challenges and the kind of cost of living crisis. Just final thoughts from you both on, how do we ensure that the current challenges economically and politically do not get in the way of us sort of meeting our sort of net zero ambitions, and how do we kind of ensure that no one's kind of left behind on this journey? David, any kind of final thoughts from you?
So yeah, it is really important we have a just transition, and we don't abandon parts of society in the quest to get to net zero and get that tick in the box as quickly as possible. So education is a key piece, understanding, and that's both education at a school and university level, but in industries as well. If industrial fuel switching is taking place, new energy infrastructure requires a huge amount of construction, providing the education piece to all those people that will interact with both the digital side and the sustainability actions is incredibly important and valuable, and promoting those new jobs, because we will see millions of green jobs that occur in the UK and Northern Ireland over the Great Britain, Northern Ireland, sorry, in the coming years. It's how do we make sure that those jobs are available to people that don't have PhDs in sustainability, and that the right training is given so that as diverse cohorts as possible are taking up these green jobs and leading this kind of industrial revolution.
Thank you, David. Maria, any final thoughts from you?
Yeah, in terms of cost of living, so I think there's, I don't know whether it's a myth, but there's a side of sustainability that suggests everything needs to be more expensive. If you're trying to be more sustainable, you need to be buying, everything at 3 times the price because it says organic. I don't know, you need to replace your gas hob with an induction hob and all of those things. I think we need to take a pragmatic look at that, and it's hard to not be political, but it is it's very possible to take a pragmatic look that actually enables everyone to look at how can I be a bit more sustainable, and as we said, also economically, what makes more sense. And often these things go in hand, and they're not often presented like that, and sometimes also because we're consumers, and we're being sold to all kinds of things, and so sometimes the idea is being sold to us that everything sustainable has to be more expensive. No, actually, you can be a lot more sustainable also by consuming less, or consuming in a selective way, saving energy. So again, education and looking at how can you save energy, which I know everyone is doing already. Insulation and government support, I think, for insulation, there's a whole host of measures that are both more sustainable and more economic. I think where possible, we all need to be, I don't know, enabling each other and education is critical in that as well, to look at what can I do that will be both more economically beneficial for me as a household or an industry, as well as more sustainable. So starting with a not doing rather than doing something else instead, where possible. But it's a very difficult question, and there is obviously a big opportunity, which I'm not sure that at the moment we're really realizing, about becoming, energy independent. If you look at it at a kind of higher level, becoming energy independent by and more relying on sustainable energy. I think right now we're not yet really headed in that direction. We're looking to plug holes with the same or similar energy supplies. So it's a challenge. If we can all try to make the crisis into an opportunity, because there is a huge opportunity to become more sustainable, where fossil fuels and gas are just becoming, for all kinds of reasons, really, really expensive. And again, I think we cannot keep going the way we are. I think any of us who have children or family who have children, even if we can keep going for another 5 or 10 years, let's pretend, just continuing to use fossil fuels and gas, this situation is just going to continue to escalate, right? I mean, it will anyway, but maybe we can rein it into a level that's viable. So yeah, short-term solutions are just not the order of the day.
No. And encouraging people not to fly probably isn't the answer either, is it? Because if they don't fly, there's no investment. So
it's a very difficult question, right? Yeah, it's all about a mix. I think a mix of measures, a mix of sort of what can we do, what are the benefits, health and social benefits of traveling and flying versus, do I always need to fly everywhere all the time? How often? What am I using to get somewhere? What type of aircraft, what type of transportation is not always that clear. So actually, driving all year is likely as bad if it's an old car as taking a flight a year. So it's a mix of measures, and there needs to be more transparency, I think, around where our levers are.
Maria, David, thank you so much. This is a fascinating conversation. Unfortunately, we're out of time, but I'm sure we could have carried on. There was many more questions from the audience that we could have tackled, but I hope we've covered most of them throughout the conversation. I've been monitoring what's been said to see whether we're answering as many of those as we possibly can. But thank you so much for your time. Thank you so much for your sharing your insights and presentations, and also obviously answering some of those quite tricky and challenging questions that I'm sure will continue to rumble on. And thank you very much for our audience for attending. Any downloads or notes on the presentations and also recordings will be shared offline after the session. So Maria, David, thank you very much, and thank you for all of those who attended the webinar this morning. Thank you. See you again.
Thank you. It's been a pleasure. Thank you.
Thanks for your time. Have a great afternoon. Bye-bye.